wrap up by looking at Chapter 7, and we're going to be on page 26 in your green notes. We are skipping Section 7.1, and we're going right to Section 7.2. So we're going to be talking about what it means to be similar to somebody. So I want you to think about being similar to somebody maybe in your family, where you look alike, but you're not identical. So unless you're identical twins or triplets or someone who is identical to someone else, you will be similar to people in your life, but you won't be identical to anybody. So similar figures look alike, but they're not the same exact size and shape. So think about maybe a brother or a sister or a mom or a dad that you might look alike. So the definition for similar polygons is going to be a little more intense than this, but we're going to start by saying that they're going to have the same shape. Okay? One octagon can't be similar to a hexagon. I'm sorry, but an octagon has 8 sides and a hexagon has 6, so they will not be similar. So they'll be the same shape if they're similar, but they're not going to be the same size. So think about a mom and a kid. So my daughter and I look pretty much alike. Like I look back at my childhood pictures and we look a lot alike, which is bad for her. But because of that, we're similar to each other, but we're not identical. I mean, we have different features, but we're very, very similar in the face to one another. So let's look at what it would look like for 2 hexagons to be similar. So what I did is I went ahead and measured all this stuff for you so we didn't have to waste the time in the video. And what we're going to do is we're going to start by looking at the angles of each hexagon. So if they tell you that these are similar, this hexagon has 6 angles, and oh wait, these are heptagons. Sorry, I thought. Oh no, they're hexagons. Okay, hexagons. They have 6 angles. So this angle C matches this angle R. This angle B matches Q. And if you go all the way around, I measured all these angles, and so the angles actually are congruent to each other, which seems weird because this is a baby hexagon and this is a bigger hexagon, but the angles still match. All right, so that's number 1. Number 2, we're going to compare the sides. Now, definitely the sides aren't congruent, just like me and my daughter are different sizes. So we're going to take the sides and we're going to make fractions. I'm going to put the big number on top of the small number. So I'm going to compare 4.9 over 2.7. Those sides would be called corresponding sides because they're matching up. And I'm just going to go around and match these up. Oops, I think I forgot to measure those. Well, we'll just skip those for now. Let's go to 0.7 is going to match with 0.4. So I'm going to match these bottom little pieces up. And then I'll go ahead and match the bottoms up. So 4.7, oops, I'm sorry, 8.4 has to go on top because that's the big one, and 4.7 on bottom. And I did not get these measured, but trust me, they will follow the same pattern. So as we start matching up the corresponding sides, I did the big ones on top and the little ones on bottom. I'm going to divide these out with my calculator, and I'm going to see what I get, what this ratio gives me. So 4.9 divided by 2.7 is about 1.8. 0.7 divided by 0.4, if we round to the nearest tenth, is about 1.8. And 8.4 divided by 4.7 would be about 1.8. So if you notice, if I continued on and did these sets of sides also, that pattern is staying the same. That means the sides are proportional to each other. They're not identical, they're not congruent, but they are proportional. So keep in mind when you have 2 similar figures, they have the same shape, their angles are congruent to each other, and their sides are what we call proportional. And you could flip all these fractions upside down and do it the other way and divide them, and they would still match. Okay, so we're going to come over here and we're going to fill in a few things. So when we measured the corresponding angles, I'll just put CA congruent. The corresponding angles were all congruent to each other. They match up and they will be identical. Then it said measure the sides and then find the ratios. How do the ratios of the corresponding sides compare? A lot of kids say that they're congruent. That is not true. The corresponding sides were not congruent. We call them proportional because these are proportions with each other, a fraction equal to a fraction. So we're going to say the corresponding sides are proportional. So that's what it takes to be similar to each other. So there is going to be a new name for what we call that ratio of all the sides that we match up, and that is called the scale factor. You may have called it that in middle school, you may not have, but the scale factor is what you get when you match up the 2 sides. So on the example I just did, the scale factor would be 1.8 over 1, because the big one was 1.8 times as big as the little one. That's called the scale factor. All right, so this is a very important box here. for what does it mean to be similar. So that's one thing this year I want you to walk away knowing. When polygons are similar, they can be triangles, hexagons, heptagons, octagons. Number one, they will have the same shape. They have to be the same shape. They can't be like an octagon with a pentagon. Number two, the corresponding angles are congruent. So that surprises kids because they think, oh, if one's smaller than the other, the angles can't match, but they actually do. And then the corresponding sides are proportional. So don't say they're congruent, say they're proportional. Meaning that the scale factor for all the sides when you match them up will always be the same scale factor when you divide them. All right, the symbol for similarity is going to be a wave, and we may have talked about that earlier in this year. It's a wave. It's like the top part of the congruent sign. So you take off the equal sign and you keep the wave. And then we're also going to be doing similarity statements. So a similarity statement is a matching up of all of the pieces. We've done this with triangles, so we're going to do it with the hexagons here. And I just want to remind you that order matters when you're writing a similarity statement. All right, so I'm going to start by saying hex, and I'm going to come over here, and I'm going to name the first one whatever order I want. So I'm just going to start, because you guys probably like alphabetical, I'll go A, B, C, D, E, F. I'm going to come over here and say my hexagon, A, B, C, D, E, F, and then I put the similar sign instead of the congruent. That is going to be similar to hexagon, and then I come over here, and I've got to start with the same corresponding angle as A. So I look down in the corner, and A corresponds with P, so I'm going to go around starting with P. So it's going to be P, Q, R, S, T, U. So I come over here and say P, Q, R, S, T, U. Just remember that the order has to match. All right? All right, so if I were going to write out all pairs of congruent angles and a proportion for the corresponding sides, I'm just going to show you this for the hexagons. So this is my answer key here. These would be all of the sets of congruent angles that would match, and here's what my sides would look like as a proportion to each other. So any two of these are a proportion, and I'm just listing the sides that match up in order of how they match. So just keep in mind that is called a statement of proportionality, and then these are all the angles that match up. Okay, so let me show you a couple examples. We're going to try some down at the bottom. So the first thing we're going to do is we're going to determine whether we think these triangles are similar or not. So we've got a couple things to check. Number one, are they the same shape? Yes, they're both triangles. Number two, are the angles congruent to each other? So do you guys see how two angles match? There's something called the third angle theorem. That will automatically mean that these third angles will have to match because they add up to 180. So I'm going to say, oh, by the way, and you don't have this in your green sheet, it's in your book. I've just copied it and put it in here. So just watch as I'm doing this because it's not going to match what's in yours. I just put the picture in here so it'd be easier than going to the book. All right, so number one, the angles are definitely congruent to each other. And that's because since two of these match, then the third ones have to match. Okay, number two, we have to check the sides. Are the sides proportional? So let's go check them. Now when I check them, what I do is I take the order of the first one and I put them in small and medium and large order. So if you look, I went and put the 11.5 first, then the 12.5, then the 15. Then I'm going to come over here and I'm going to match up small, medium, large. The smallest is 9.2, the medium is 10, and the biggest is 12. And I'm going to see if my sides are proportional. So this is as easy as just taking your calculator and dividing them. So I'm going to divide 11.5 divided by 9.2. I get 1.25. Okay? Now obviously you can tell in the next one, 12.5 divided by 10 is 1.25. And we just need to check 15 divided by 12. We get 1.25. So that means the sides are proportional to each other because they all reduce down to the same scale factor. So the sides are proportional. So now we know that yes, they are similar. So I'll say yes. And then we're going to write a similarity statement for what this would look like. So watch as I match these up. So I'm just going to name the first one however I want. I'm going to go N, Q, P, and I'm going to say that that is similar to, now I have to be careful. So N matches with R, and then Q matches with S, and then P is going to match with T. just like we matched them up when we said that the triangles were congruent. That's called a similarity statement. All right? Okay, so let me show you another example. Again, this is not in your green. I just pulled it from the book so I could show you one that was in your notes. So this time I'm going to give you two that are similar, and we are going to find variables. All right, the very first thing you should do when you're trying to find the variables is look for a scale factor. So I want to find two things that actually match up. So I'm going to look at CD and WY, because CD is the second and third position, and so is WY. That means the 9 and the 6 will make my scale factor. So my scale factor will be 9 over 6, or you could put 6 over 9. Now, probably the easiest thing is to reduce it so that your scale factor is in lowest terms. So 3/2 is my scale factor if I reduce it to lowest terms. Okay, so let's use that to help us find x. And you did this in middle school. So 3 over 2 equals, now if I want to match x up, x is FD. That matches with YZ. So these two go together. So that would be x over 10. All right, I'm going to cross multiply. So that's 30 equals 2x, and that's x equals 15. Now I'm going to do the same thing to find y. So I'm going to start with my scale factor. I always write down my scale factor first. 3 over 2 equals, now when I go to match up y, y is VZ. VZ goes with AF if you look at the order. So I'm going to do AF on top because the 3 was on top, and then 3y minus 1 on bottom. Okay, I'm going to cross multiply. I'm going to get 9y minus 3 equals 24. 9y equals 27. So that's going to give me a y equals 3. So basically you're using your scale factor to help you create a proportion to solve for a variable. All right, so let me show you one thing. So if you flip back, we're just going to finish off with this last question up here. And we are going to talk about these triangles and rectangles being similar and finding a scale factor. So it says that these are similar already. So it already tells you that. That means they're the same shape. That means their angles are congruent and their sides are proportional. So it says set up ratios for the corresponding sides of the similar figures and then find the scale factors. All right, so this is on page 28. Here's what I do when I want to find the scale factor. I look for the smallest side of one and I put it with the other. So it can be any of these sides. So I'm going to go 36 is the smallest of this. I'm going to put it over 30. But technically we could use any of these sides. We could use the medium or the large. It doesn't matter. Now we're going to reduce this. So 30 reduced, if you divide it by 6, is 5. And 36 is 6. So your scale factor is 6/5. So kids will say, or could I say 5/6? Well, if it tells you what order to put it in, you have to put it in a certain order. But this could be either one. It doesn't really matter which order that you give it in. You're just putting a piece of one that goes with the corresponding one of the other. And again, I did the two smallest, but you could do the medium or the large. Okay, so let's do it with the rectangles. And again, as long as you're matching up the pieces that go together, so the easiest would be the width of this rectangle with the width of this one. So this would be 9/5, or again, if it doesn't tell you, you can put 5/9 unless it specifies the order. So those would be the scale factor that these would use.